Hydrogen bonding. In this video, I am going to discuss as a condition for hydrogen bonding and definition, types of hydrogen bonding, and its applications. So, hydrogen bonding also another special case of dipole-dipole attraction that we'll discuss here. You can see first basic definition. Hydrogen bond is often observed H bond, the primarily electrostatic force of attraction between a hydrogen atom which is covalently bound to a more electronegative atom or group, particularly the second row elements nitrogen, oxygen, fluorine. The hydrogen bond donor and another electronegative atom bearing a lone pair of electrons, the hydrogen bond acceptor. So we'll see that one the representation generally donor hydrogen atom and acceptor this is. So they are showing hydrogen bonding which is they given three dotted lines that's showing hydrogen bonding. This IUPAC recommended that one, but in different books they are writing more number of lines. Okay, that they convince, but officially they are showing only three dotted lines. So discuss this definition with respect to one example. I can take it HF. HF. This is the molecule. So one of the conditions they are satisfying hydrogen should be attached to NOF. But some books they given chlorine also. So you may can consider this also. So you can see here hydrogen is the electropositive element, or you can see here F is more electronegative atom. This bonding electrons moving towards fluorine. So that is the reason we will get delta positive means partially positive character here partially negative, and this is partially positive same partially negative. Here this bond is forming in covalent compounds only, not ionic compounds. That should be partially, and this partial positive character attracting lone pair of another atom, which is more electronegative atom. They attract disease. This type of bonding between two molecules, in that case hydrogen should be attached to the more electronegative atom and hydrogen participating. This type of bonding we call hydrogen bonding. Hydrogen attracted towards another molecule more electronegative atom lone pair. Okay, and we are representing three dots. And I use that word. This is a special case of dipole-dipole attraction. This is one of the dipole. This is another dipole. Clear? This is the two dipole-dipole attractions. And here, which is the hydrogen going to be donating here? HF is donating. This is that. That's why you can show this is DN donor, which is accepting hydrogen dot. That's we call acceptor AC. So here donor hydrogen acceptor. Acceptor should be attached to dotted line. So this is acceptor. This is donor. So this is the case, special case. This is strong attraction forces. This attraction is hydrogen bonding attractions is more than van der Waals force of attractions. Okay, and but this force of attractions is lesser than ionic bond and covalent bond. This is lesser than ionic and covalent bond. Try to note down the points. Now I am going to be see here. Generally, this hydrogen bonding is classified the following types: intermolecular hydrogen bonding and intramolecular hydrogen bonding. Intra means within the molecule hydrogen bonding formation. Inter means between two molecules. Between two molecules. So for example, here OH is there and here fluorine. Those can form easily hydrogen bonding. Within the molecule they are forming hydrogen bonding. That is we call intramolecular hydrogen bonding within the molecule. Intermolecular between two molecules. I shown already with respect to HF also. Okay, between two. H2 also can form hydrogen bonding. This is partially negative, partially positive character. With respect to other water molecules, they are showing negative and positive. This type of hydrogen bonding. And it increases solubility, it decreases solubility here, and boiling point, melting point also increases by intermolecular hydrogen bonding, and this is strong bonding. So remember these 3 points. By using these 3 points, we are going to discuss its applications. So again, one more time, you can see this is strong bonding. Intermolecular hydrogen bonding is strong bonding. Strong bonding means it have more boiling point, melting points. Fine. unstable also molecules because strong bonding. Next, intramolecular it is weak bonding. So whenever they have weak bonding means while boiling point, melting point is anyway less and less stable also these molecules compared to intermolecular adjoint bonding. Got it? And solubility extra. And due to intermolecular adjoint bonding, viscosity also going to be increases. Viscosity of the substance or liquid going to be increases by intermolecular adjoint bonding. Intra may not be increases that is. Got it? So we'll see again this intermolecular adjoint bonding two types. Homo internuclear because both are same molecules. That's we called homo internuclear between two molecules. Heteronuclear, one is HF, other one is H2O. But they are forming here generally NOF. All these are which is attaches to hydrogen, they are forming hydrogen bonding, which is strong hydrogen bonding. Next question. That depends upon some other factors. Mainly you can consider here electronegativity difference. Which one have more electronegativity difference, it can form strong hydrogen bonding. F can form strong hydrogen bonding compared to oxygen nitrogen. You may can consider F can form strong hydrogen bonding compared to nitrogen and oxygen. That depends upon electronegativity difference. F have more electronegativity compared to oxygen than nitrogen. So this is the hydrogen bonding art also you can find out. This is clear. Now I am using one PDF to discuss here all the things. We can complete easily and applications also. Okay. Now you can see here types of hydrogen bonding. We seen that one internuclear and intramolecular. You can find out here very clearly water forming how many hydrogen bondings are. This is, please check it here. So in water, four hydrogen bonds they are forming. That's that one. One water molecule they are forming four hydrogen bonds. Homo internuclear hydrogen bonding they are forming how many? Four. So you can count this the one of the important question already they given. And you can keep in mind solid state they form more number of hydrogen bonds. Solid state more number of hydrogen bonds, more hydrogen bonds they can form. Then gaseous state is the least number, gaseous state. Less number hydrogen bonds, less number hydrogen bonds. Clear? And heteronuclear means between two different molecules. Already I discussed that with the example. I think we don't want to discuss that is like this. Then applications we can see intramolecular also already we discussed that one. If you want you can see here definition they provided. It takes place within the molecule like that. So you can check it here. Within the molecule they are taking place. That's we call intramolecular. OH and then what is we call orthonitrophenol. This salicylaldehyde like these examples. Within the molecule they are forming hydrogen bonding. That's we call intramolecular hydrogen bonding within the molecule. Now effect of hydrogen bond on physical states. This is more important and application oriented and easy also these things. So what is the first application you can see here? Solubility. Already we discussed that one. Due to intermolecular hydrogen bonding, they are soluble. Actually, alcohol, they are forming hydrogen bonding when dissolved in water. That's why alcohol is soluble in water. So that is the reason most of the alcohols, which is their bar shop or wherever you are getting wine shops, alcohol and water they are mixing each other due to hydrogen bonding. Due to hydrogen bonding. Next time you can remember whenever you are thinking alcohol, why they are soluble due to hydrogen bonding. And some other examples also they are giving. Acetic acid also going to be soluble in water. Glucose, fructose, all these things. Even supposed to be hydrocarbons should not be dissolved in water, but they are soluble in water due to hydrogen bonding only. Due to hydrogen bonding, they are soluble. CH4 doesn't soluble in water because in this case hydrogen does not attaches directly NOF, so it can't form hydrogen bond. That's why it is not soluble in water. So some other examples they given. Even a stone doesn't soluble in water because it oxygen does not attach us to the directly oxygen ketone. So ketone structure this is only can take it example. Acetone is one of the ketone. and ether. Oxygen doesn't attach us directly oxygen, so they can't soluble in water. And intramolecular hydrogen bonding decreases the solubility. Decreases the solubility. Intramolecular hydrogen bonding decreases the solubility. How that is decreases, we'll discuss here. So this is the, I'm taking one of the molecule. Here, suppose OH is forming in the solvent. Solvent is the water, sir. Solvent is the water. You can imagine always I'm taking one beaker is the water, I'm dissolving substance. Okay, you can like thinking this is solvent. But here, suppose OH is forming with water that can soluble. But before forming this bond, within the molecules they contain oxygen and hydrogen, they are forming hydrogen bond. Due to this hydrogen bonding, is not able to forming hydrogen bonding with water. That's why insoluble. That's why insoluble. Got it? These names and structure they provided. Please observe that one. Next, intermolecular hydrogen bonding. This can form easily dissolve in water because this is the OH that maybe can dissolve in water. Water and this H can form because there is no here intramolecular hydrogen bonding. If intra is there, they can't solve. It can form easily with water, hydrogen bonding, they can soluble each other. Viscosity. Hydrogen bond associate molecules together, so viscosity increases. That's common point. More the hydrogen bonds, then more the viscosity. You can find out here very simply. Here three OHs, it can form more hydrogen bonding. Here only two OHs, it can form less, and it is still less. So viscosity order. And here water also. Okay, it can form more number of hydrogen bondings. The things are given solid state. Already counted four hydrogen bonds. And here one, here no hydrogen bonding, that's why less viscosity. Even you can check it boiling point also. Wherever more number of hydrogen bondings, that have more boiling point also. So here water have more hydrogen bondings, and this is less, this is still less. So you make and write boiling point order also. Got it? So higher the hydrogen bonding, higher the boiling point. Melting point and boiling points. Due to intermolecular hydrogen bonding, melting point and boiling points of the compounds increases. Correct. Same which we discussed directly, that's only here they are telling. Trihydric alcohols, 3 OHs. Trihydric alcohol means these are the things. 3 OHs. Next, dihydric means 2. Mono means 1. So more the OHs means more the boiling point and melting point. And same thing you can say carboxylic acids also. Carboxylic acids form stronger hydrogen bonding than alcohols compared to molecular weight, comparable molecular weight. Suppose I am taking here based on this point, carboxylic acids means COH group is there, that is CH3COOH, and I am taking C2H5OH. This is the alcohol OH and acid group. Which one have more boiling point? Here they given very clearly. Hydrogen bond is strong in the case of acids. It can form strong hydrogen bonding, so more boiling point. So just observe remaining examples also. So HF can form hydrogen bonding. That's why it have more boiling point. You can check it. HF is strong hydrogen bonding compared to all these things, more hydrogen bonding. H2 also have hydrogen bonding, that's why more boiling point. Just compare all these things. Ammonia also hydrogen bonding, that's why more boiling point than these two. Got it? And next application, this is more thing. Compare H2O, HF, NS3, which one have more boiling points and melting points. Supposed to be HF should have more boiling point, but compared to H2O, but here HF is strong hydrogen bonding it can form. That is the reason it can form hydrogen bonding in vapor state also. It can forming by breaking easily few molecules. Itself it will break two molecules, it can form evaporate and it can form hydrogen bonding in the vapor state also. it can ready to break these bonds. But water have too many hydrogen bondings, like four they are forming and more. Okay, so you may can check it reason here. Intermolecular hydrogen bonding gives rise to the ring formation. So the force of attraction among these molecular van der Waals forces. So melting point, boiling point are low. That's remaining cases. But here H2 have more boiling point than HF. Even molecularity is more for HF also. Reason they have more number of hydrogen bondings. One reason you can say that word. And HF is strong hydrogen bonding. It can form in vapor state also hydrogen bonding. That's why they're ready to evaporate. Got it? Next, you can check it here. Already we know that one hydrogen forming a carboxylic acid is forming hydrogen bonding. This is one of the carboxylic acid. It can form hydrogen bonding. What type of hydrogen bonding? This is intermolecular hydrogen bonding. Intermolecular hydrogen bonding between two molecules. They are forming hydrogen bonding. Even formic acid also can form hydrogen bonding. This is the formic acid structure. Double bond O, OH. You can write another formic acid structure by writing like this. Now they can attract each other. This is hydrogen bond. Instead of R, I am writing H on. That's enough. And physical state. H2A exists as liquid state, and but H2S exists as gas state due to hydrogen bonding. Only one reason, due to hydrogen bonding. And next application you can see here, even water they are forming four number of hydrogen bonds. Four you can find out here very clearly in the solid state. And this basic strength, all these things we need to know organic something. So that's I'm not discussing here. Next, strength of acids, you can check it, which can form hydrogen bonding easily. Those can release easily H plus ion. Got it? By removing H plus ion, they're getting hydrogen bonding. So which can release easily H plus ion means that is strong acid. One more exceptional stability of chloral hydrate. Generally, chlorine doesn't form hydrogen bonding, but I given that cases, one special case, this is hydrogen bonding. Supposed to be any carbon they contain two OHs is highly unstable. It can lose water molecule readily, then they can form here double bond O plus H2. But here still two OHs is there means reason they are forming hydrogen bond. That is the reason this is stable. This we call chloral hydrate, name of the compound. So here they're explaining acidic character. This is cis compound. If two hydrogens same side, that's we call cis. You're going to learn properly in organic chemistry. Just I'm giving basic definition of cis means. They are ready to form hydrogen bonding by releasing one hydrogen. So they're releasing H plus easily means that is strong acid. So why they are releasing H plus easily means to get hydrogen bonding. So this the releases easily H plus means strong acid. But in the case of here, there is no hydrogen bonding. That's why they can't release easily H plus ion. And finally, which is we studied chemical bonding, what type of bonds and their strength they given order. Ionic bond is a strong bond. Next covalent, metallic bond, hydrogen bond, van der Waals force or attractions. Thank you very much. Try to subscribe and share this video. Thank you.